Hello, this is Jesse Miles. This is my chapter 15 homework here. I started it very late at night after work, and so I realized too late that you were supposed to do the last problems first and then work backwards. So I did number 1 first, and then I realized that we were supposed to start at 10. So I'll just start with 1 since we're here. This was the one with the 2 rods that had different radiuses on them, basically kind of seemed like a gear type thing. But for the left, we had t equal 41.888 times 2 over 24, and then you get that. Middle, really all this was just changing the top and bottom numbers, which I believe were the what were those? Those were the radiuses, so it was one of them over the other. Okay, next one, we had omega equal omega I plus omega 2k, and this was kind of fun. This reminded me kind of statics, because I seem to remember a lot of statics was doing cross products, so it was kind of fun to go back and do that. I haven't done cross products in kind of a while, actually, but basically you get through all of it here, and we find our acceleration of p, a of p, or a sub p, and that was that vector, the ij and k. This problem was quite long. As you can see, it took up almost 75% of the page, but yeah, I'm not going to talk through that. That'll take way too long. But basically, it was that one with the collar on the bar, and then I believe it was moving down there at point A, if I remember correctly. But you do the law signs, you find AP and BP. Yeah, there was kind of a lot going on with this one, but anyways, you segregate things down into I and J components, and then you can go ahead and solve for angular acceleration of BP, which was 81.15 radians per second squared, and then u dot, which was 3.064 meters per second squared. Next one. Oh yeah, right, this one was the one with the wheel. I drew kind of a small picture because I wanted to fit this on one page. I don't even know if I did. Yes, I did. So it worked, but it's a very small picture there, and it kind of confused me. So now I know. But basically you have these different forces here, different accelerations, velocities, going in different directions. And let's see here. I believe we were looking for acceleration here on most of these. So acceleration of G I got was 45 inches per second squared. And let's see, acceleration of A, 48. Acceleration of B, 85.4. And acceleration of C was 82.8. And see, acceleration of B and C both had an angle associated with them. Okay, and here was the other one that was similar to that one that had a collar, except I don't think this one had a collar. Basically, you can get that angle beta, just sine of beta equal 1/2, so obviously it's 30. And then we come down here and looking for, what was that, angular velocity, BC there. So 45 RPM going clockwise, converted to radians. And then, let's see here, sorry, I was kind of tired when I finished this, so I almost don't remember. We have, right, angular acceleration of AD, which I got was negative 12.821 radians per second squared. And so you have a D, I think that was a D, right? I don't even know what I wrote. Almost looks like A naught, actually. 184.9 inches per second squared. There is an angle 16.1 degrees associated with that. So there was a lot of, like I said, kind of, it reminded me of statics problems, pretty similar actually, except things are moving, right? So this one down here, we had I and J components again, and you solve for them, and you get the 14.76 inches per second there is your V sub E. And try and go through it a little faster because my phone's not good at uploading long videos. So and again, I and J components, that was kind of the theme here for a few of these problems, was getting them into I and J components and then going from there. And let's see here, yeah, pretty much it. Using cross products and your basic equations, your delta theta down here, T final. Yeah, not too bad. And that is it. Thanks.